Good day everyone. Today I'm going to be talking about electrical circuits. When we talk about the electrical circuit, the electrical circuit. Good morning to you today. Today we're talking about electric circuits. The electric circuit is a complete part provided for the flow of electric current. This is what we represent current by I, whereby we say the I is the current, the unit is amps, simply A. Then we have the resistor. It has units of ohms. Then we have the capacitor. The unit of farad. We have the inductor. And an inductor whose unit is Henry. That's H. So now when we're talking about electric circuit, in terms of the calculation, we have what we call the Ohm's law, which says voltage equals current multiplied by resistance. That's V equals IR. The voltage is the potential difference between the lowest point and the highest potential, meaning the difference in the voltage. If, for example, if we have the difference in this voltage is what we use as the voltage, meaning for the potential difference, this is a cell, but when we have more than one cell, it becomes a battery. Arrangement of cells together. If we have a voltage supply of 12 volts, then we have a current I, then we have a resistance, for example a resistance of 6 ohms. To calculate the current here, we say voltage equals IR. That's because this is the total resistance, neglecting the internal resistance of the cable itself. We don't have any other resistor here. This is the total resistance in the whole circuit. So that's like saying the total voltage equals the total current multiplied by the total resistance. That will be 12 volts equals I times 6 ohms. Then using we divide two sides by 6 ohms. So we have 12 divided by 6, that's gonna be giving us 2 equals I. Note the unit of current is amps, therefore current is equal to 2 amps. Now if we have more than one resistor in a circuit, if we have more than one resistor in a circuit, for example it's still 12 volts, then we are having about 3 ohms and 2 ohms. So now the total current is what we don't know. To calculate this current, we come here. Now we're gonna be cross multiplying. Naturally 12 volts is already divided by 1. By cross multiplying, we multiply 5 by 1 and 12 volts times 6. That's 12 volts times 6 equals 5 multiplied by current times 1. So we're going to be having 6 times 12. We'll be having 72 volts equals 5 multiplied by current, dividing both sides by the coefficient of the unknown, which is 5. So we are having the current equals 14.4 amps. So now this is the situation for series circuit. Why this is for what? The parallel circuit. All you need to know is that in series, please take note, in a series circuit, this is the total current. The total current is the same all through. If this was 12 volts and the current here is 2.4 amps, definitely the current here will still be 2.4 amps, 2.4 amps, 2.4 amps. But the resistance will be different. There is R1, R2. Also, each resistors have internal voltage drop across them, which is opposing the current, the conventional current. So it's opposing it. This will be V1 and then this will be V2. Therefore, we say the total current is equal to the current in is the same as current in the second device. But for the resistor, the total resistance in the circuit is a summation of the two resistors. Why? For the voltage, this is the EMF and these are the voltage drops. So we say the EMF is equal to V1 plus V2, or V, the total voltage equals V1 plus V2. This is for a series circuit. But when we talk about a parallel circuit, this is the current coming in. When it gets here, it breaks into two. We have the I1, we have the I2. Now, this is R1, this is R2. Then we have voltage drop across R1, which is V1. We have voltage drop across R2, which is V2. Then these two currents recombine at the end there, coming out to still be the total current that came in. Meaning the total current that came in is the total current leaving the circuit. Also, please note the total voltage coming in after the whole dissipation and the meeting together, the whole voltage drop in the circuit, this will still be equal to the total voltage coming out, meaning total coming in equals total coming out. In this situation, we have the current, they are not the same. We have I, which is the incoming current, is equal to I. Yeah, let me reiterate by saying that the total current is equal to the summation of the two divided resistors, which is I1 plus I2. Then for the resistance, the total resistance in the circuit, since it's in parallel, it will be 1 all over R1 plus 1 over R2. But thereby using LCM, we taking both, multiplying them together, R1 times R2. R1 in R2, it's gonna be cutting R1, remaining R2. R2, that's the denominator. The R2 multiplying by 1, that will be R2 plus R2 here. We remove R2 from here, so we're going to remove R1. R1 multiplied by 1 is to give us R1. Thereby, we having R1 plus R2 all over R2, R1, R2. Now, for the total voltage is equal to, here in parallel circuit, the voltage they are usually the same, meaning the voltage coming in will be the same. The voltage drop in V1 is the same as V2, so we have V1 is equal V2, or total voltage equals V1 equals V2. Thanks for watching.